Question number 5 has to do with using the fact that the derivative and antiderivative undo each other. So here I have the integral. This part is my integral, and I'm going to differentiate that integral. Well, when I do that, basically I'm going to have the derivative and antiderivative undo each other. So we just have to be careful. As long as that's equal to x, the endpoint is x, we have any arbitrary starting point, we're going to differentiate this antiderivative and we're going to get back to the original function. So as long as that endpoint is x, the answer to this is going to be just, we plug in x into this expression. So it becomes x sine log 1 over x squared, and that's it. Okay, we would have ended up with the antiderivative plus c. We differentiate that, we end up losing the plus c and getting back to the original expression. So this expression has to match this expression if we have the derivative and antiderivative undo each other. Now there's a slightly different scenario when we have this endpoint being x squared. Okay, if the endpoint itself is a function, when we undo this, we're going to embed that function into the antiderivative, and when we differentiate, we're going to generate the same original expression, but because we embedded an x squared, we have to add on a chain rule. So it's going to look like this. Again, the derivative and antiderivative are going to undo each other. So I'm going to end up with log squared of arcsine square root. Now I have to plug in the endpoint into my expression. But because I have this endpoint that is not just x, what I've done is actually embed that function into the antiderivative, and as I differentiate it to generate the original expression, I have to remember to apply the chain rule. So I have to differentiate that endpoint of 2x because that's an embedded function. So again, the same thing is happening. This has to match what we have here. But because we have a t and the endpoint we have to plug in for t, we get x squared here. And because the x squared is itself a function, we have to make sure we add on times 2x, which is the chain rule.